Okay, welcome back grade 10s. We are now going to have a look at solving exponential equations. And let's start off with how we identify our exponential equation, okay? So the first thing we notice, obviously, is that we have a variable in the exponent. That is immediately telling us that we need to apply our exponential laws in order to get hold of that x so that we can solve for x, right? The other thing I notice is obviously there's an equal sign, and I love working with equal signs because it means that I can easily take things over to the other side. And really what the idea is just to basically chip away at that x and solve for x. So we're going to chip away, we're going to rip everything off of that term so that we can get to the x, and by doing so we are going to solve for x, right? So here are some tips very quickly. Basically, what we want to do is, again, make all of our bases the same. Okay, they need to be prime numbers again, as we've been doing in the previous couple of videos. We're going to simplify into the point where we can drop the base. Once we drop the base, we solve our equation as we have in previous years. Okay, we're just going to take everything from that x so that we have x as our only variable, and we can figure out what x is equal to. So we're going to start off with the basic type, all right? And we're just going to do a couple of examples here. Let's start off with the first one that says 3 multiplied by 2 to the power of x plus 1 is equal to 6. Now again, our goal is to get to this x. So this 3 that's living on this side can be thrown over to the other side. We're going to take it over the equal sign. And if it's multiplied on the left-hand side, it's going to be divided on the right-hand side. Think of that equal sign as being like a wormhole through which, if I take that 3 over to the other side, it is going to become inversed. Okay, what I mean by that is that if it's multiplied on this side, we are going to have 6 divided by 3 on that side. Okay, so we have 2 to the power of x plus 1 is equal to 6 divided by 3, which is 2. And I'm happy now because both of my bases are 2. Now we can think of this as being 2 to the power of 1. So in this case, now that both the bases are the same, we can drop that 2, and what we get is x plus 1 is equal to 1. We're going to now pull everything over from this side. We are looking to get x by itself. And what we find is x is equal to 0. Because this 1 comes over to the other side, it's going to become a negative 1 on the other side, and x is now equal to 0. Okay. Next up, we have 3 to the power of x plus 4 is equal to 31. Our goal, again, is here to get to this x. So I'm going to take this positive 4, and I'm going to move it over to the other side. So what I get is 3 to the power of x plus 4 is equal to 31 minus 4. Now 31 minus 4 is equal to 27. And when we see this number 27, we should immediately be able to identify that, hey, 27 is equal to 3 to the power of 3. Okay, so I am just going to take a step there quickly and convert that. That's a 3. And what I find here is that my bases are both the same. They are both 3. So I'm going to drop those bases. What I get is x plus 4 equals 3. Now the goal is to get x by itself. So I'm going to take that positive 4 over to the other side. It's going to become a negative 4 on the other side. So we get 3 minus 4. And then we find that x is equal to negative 1. All right, so let's do another example. Now, when you guys see this fraction over here, you need to identify that, first of all, we can change this 8 to become 2 to the power of 3. Okay, and once it's 2 to the power of 3, because currently it will be 1 over 2 to the power of 3, we can take this up to the top. And what we find is this will become 2 to the power of negative 3 by doing so. So let's do it step by step to show all our working out. This is 1 over 2 to the power of 3. Okay, the next step, I am going to take this up to my numerator by inversing it. This becomes 2 to the power of -3. Now both my bases are 2, so I can drop my bases, and I end up with 2x plus 1 is equal to -3. Now our goal is to get to the x again, so I'm going to bring this -1 over to this side. What I end up with is 2x equals -3 minus 1. So 2x equals -4. Okay, and we need to get the x by itself, so if it's multiplied on this side, it will be divided on the other side. So x is equal to -4 over 2, and therefore we find that x is equal to -2. All right, let's do another example. This one, I can immediately see that I'm dealing with the base 7, that is a prime number, but then I also have this 49 over here, and now 49 is very simply 7 squared. So I'm going to start by making all the bases the same. This is x plus 2 is equal to 7 squared. I'm going to put that in brackets. That's to the power of x multiplied by 7 2x minus 1. If I had to quickly simplify that, we find that this becomes a 7 2x multiplied by 7 to the power of 2x minus 1. And now some of you might be thinking, hey, should I split this using my inverse law? Well, it's not necessary in this case. We actually want to combine these together, because once we have the bases together, right, and the bases are the same on the left-hand side and the right-hand side, we can then drop the base. Okay? You also might be thinking, hey, can I just drop the base now? That would be incorrect, because if I had to drop the base now, just for argument's sake, you might end up with something that looks like this. Be very, very careful. This is incorrect, okay? We need to glue these together first into one base, and then we can drop the bases. Okay, so what does that look like? Very quickly, what that looks like is 7x plus 2 is equal to, now I'm going to take these exponents and add them together because they are being multiplied by each other. So what I get is 7 to the power of 2x plus 2x minus 1. So 7 to the power of x plus 2 is equal to 7 to the power of 4x minus 1. Okay, and now that we have these bases on their own, we can drop these bases. What we get is x plus 2 is equal to 4x minus 1. And we can solve this using our typical methods. I'm just going to bring all the x's to this side. I'm going to bring all of my constants to the other side. So I get x minus 4x is equal to -1 minus 2. That becomes -3x is equal to -3. And we find that x is equal to 1. Because I'm dividing both sides by -3 over here. So x is equal to 1. Okay. Here is another example. So in this example, we have a fraction. So we have a numerator, we have a denominator, and then we also have this fraction on the side here. So how should I deal with this? Well, let's start off by identifying that our base is the base 5. This 25 can very, very easily become 5 to the power of 2. That would actually be 1 over 5 to the power of 2, which would then become 5 to the power of -2. So notice how I haven't even started yet, but I'm already identifying exactly what I'm going to do. Now I'm going to do it step by step, okay? Because these bases over here are the same, that means I can subtract their exponents. So let's start off by doing that over here. That's going to be 5 to the power of 2 minus x minus x. That minus x came from here because it's in the denominator. Right, I'm going to take this one step by step, make sure that I'm getting full marks. 25 becomes 5 squared. On the left-hand side, we have 5, 2 minus 2x is equal to, and now I'm going to bring this one up to the top. Okay, so it becomes 5 to the power of negative 2. And now that both my bases are the same, I can drop them. And what I get is 2 minus 2x is equal to negative 2. I'm now going to do a little bit of rearranging. I'm going to bring this 2 over to this side. So I get negative 2x is equal to negative 2 minus 2. And therefore x is equal to negative 4 divided by negative 2. And x is equal to 2. All right. So that is very basically our simplest type of exponential equations, how to solve them. We haven't split anything yet. There has been no need to do that. But in the next section, we'll look at some of our other types. Thank you very much.